Raise your hand if you've gotten one of these. Now, keep your hand raised if you've totally ignored it, replied stop in all caps, gotten really frustrated, swiped right, deleted it really quickly, or thrown your phone across the couch, said I'm getting too many of these, I can't do it anymore. At best, when we get messages like this on our phone, we're feeling overwhelmed. I'm spending time sorting through things I don't want with recommendations that are not pertinent to me and ads of things that I don't really want. After many interactions with the same store, with the same brands, I want to be remembered. I want it to feel less like a chore and more like finding what I was looking for. Messages like these add unnecessary friction into our day. So what's missing with this equation? It's personalization. At Attentive, we believe that consumers crave personalization and it drives loyalty. We saw the number of hands raised in this group, and the data also backs it up. A vast majority of people also ignore these irrelevant messages. And on top of that, the same vast majority of people want a personalized experience. And we really believe that that's what drives loyalty with brands and a better digital shopping experience for all of us. If you're going to get one of these messages, why shouldn't it be relevant and individualized to you as a consumer? So why does this all matter? Let's take a quick example of myself and Eric. I'm Christian. I lead the ML platform at Attentive. I'm here with my colleague Eric, who leads our machine learning organization at Attentive. And we are very different people. I, on the one hand, ride a single speed to work every day. I go hiking every weekend, and I find endurance biking fun. Eric is a Boy Scout that hates camping. He lives down the street from Zendaya, and he's also worn the same brand, make, and color of jeans for the last 10 years.
I got to unsubscribe and save.
So then, why would we get the same message? This doesn't make sense. We're very different people. We're very unlikely to buy the same thing. And for both the brand and ourselves, it's a waste of time. Again, we really believe that personalized content is what truly drives engagement. A personalized message that includes things like my name, things I'm interested in, personalized recommendations that are pertinent to me and my lifestyle, and also product recommendations that take into account my past purchases and behaviors. These are all things that really drive engagement. And here at Attentive, we're working with thousands of the world's leading brands, household names like some of these logos here on the right-hand side of this slide, to really create those bespoke shopping experiences for consumers with the brands that they love. We, on average, are driving 25% higher online revenue for a lot of these world's leading brands. And there's a very, very good chance that every single person in this room has received a marketing message from us. So great. We've defined a little bit of the problem. We've seen the scale of it. So what are we actually doing about it? I'll hand it over to my colleague Eric to talk a little bit more about what we're actually doing about this problem.
Thanks, Christian. So we've been investing heavily in personalization at Attentive for years now. One of those investments and one of the first models that we built were product recommendations, taking the products from our brands and recommending them to subscribers of those brands. One of the great things about Attentive is that our scale affords us a lot of data. We have 8,000 plus brands on our platform, something like 3 quadrillion data points, I don't know, something like that. More than 500 million active subscribers. And just last year, we sent 57 billion marketing messages, which is kind of a lot. So large amounts of data are great for ML, as we all know, but it can also create quite the challenge. And so as we started on our product recommendations journey, we had to start small. So our first model, which was in 2022, 2023, was a classic product recs model, non-negative matrix factorization. It only looked at the interactions between a user and a product. This was largely to deal with the scale of our data. Our infrastructure didn't support us going to a much larger model just yet. So we created one model per company to help us keep that data smaller, and we trained them in parallel. We then stored the top K recommendations as into a database, and then we effectively just sent out messages with that. That created a number of problems. The positive is we proved out the value of product recommendations. We were able to actually continue to invest in that as a company. But the trade-offs that we had to have in going with this approach quickly started mounting up. We had a number of models that we had to maintain. It started turning into more like 50 to 100 models. We didn't actually have any of the product context, things like descriptions, images. We didn't have anything around the subscriber, their demographics, where they came from, referral sources, locations, et cetera. All of these things we had available at Attentive. We just didn't have the ability to put it into this model. But worst of all, it was costing us a ton of money. It's like 300 grand a month, and we weren't even serving 10% of our total subscriber base, which is insanity. Secondarily, it took 70 hours for us to train this model. And because of the model type, we couldn't actually run inference, so we had this cold start problem, which means that we were running this thing constantly. And for our customers, they're updating their product catalogs literally in real time, and we weren't able to keep up with them. So we needed a new approach that solved this. I don't think that this surprises anyone that's done product recommendations. It's a standard two-tower model. It allows us to bring in product attributes, user attributes, as well as those interactions. It trains two towers, one for user, one for product, and we were storing all of these embeddings inside of a vector store. What's great there is that now we actually have the ability to train or to do inference on net new product and net new user as they come on. So we don't have to constantly retrain, and it's much more efficient that way. We kind of knew this coming into it, but we ran into some issues with our scale really, really quickly. While it unlocked a ton of value, enabled us to prove that this two-tower model architecture would be much better, somewhat foreseeably, our data size became a limiting factor as we had a single node that we were training this model on. We had to sample the data to 20 million rows by about 100 features. And so if you have 500 million subscribers, that doesn't really work that well. We also had to limit our model complexity because we have to store our entire embedding tables inside of GPU memory. So the actual architecture of the model became a limiting factor there. And then it still took 45 hours to train the darn thing, but largely because our GPU utilization was so poor. It was trading off between ingesting data and putting it into a GPU and back and forth. So we prioritized looking at our infrastructure. Seems relevant to today.
So let's talk a little bit about the state of our infrastructure at that point in time. We were a very early, very young machine learning platform team. We ran a pretty standard Kubernetes-based ML platform where we had training dataset partitions, horizontally scaled pods. That's where we scheduled our workloads, and then we'd eventually train models off those. But there were a couple of initial challenges with this that kind of led to a lot of the things that Eric was just talking about. The main one being that we were parallel but not distributed. So that caused a couple of problems for us. For one, we couldn't shard training dataset partitions across pods. And that created a secondary downstream problem of a lot of our natively scaled pods running out of memory. We actually got to a point where during trying to scale up for the training runs with Eric's team, we ran out of AWS EC2 instances that we could physically fit the amount of data we were trying to fit into memory. And we essentially were completely capped from a hardware perspective. Probably a problem a lot of you have faced in this room as well. And on top of all of that, we couldn't actually do model combination across pods into a parent or a foundational model, which meant as Eric's team and the machine learning team were continuing to develop their different models, they were doing individualized models that had specific use cases rather than foundational models that they could continue to invest into and optimize for a single point of focus. So as the machine learning team was investing into the two-tower model that Eric was just talking about, Eric and I got in a room about 1.5 years ago, kind of in the early fledgling days of our machine learning platform, and we talked about this challenge. And what we really came to is that our infrastructure was not only limiting our personalization efforts, but our personalization efforts at scale. And we recognized at that point in time that we were about to hit what we coined our AI platform compute inflection point. This is kind of what we defined as, on the x-axis, as we wanted to continue to increase our machine learning performance and our machine learning scale to reach that platform steady state, the golden zone, we were looking at a step function in complexity to essentially bring and unlock the infrastructure to support the modeling efforts that we wanted to go towards. So at this point in time, as we were going through those two-tower migration efforts, we knew that we wanted to invest proactively as a machine learning platform team to break through this compute inflection point and invest into an infrastructure framework to support the next generation and the next future of modeling and scale at Attentive. So let's talk about how we actually solve that compute inflection point. Obviously, we're here at a Ray conference, so we chose Ray and Anyscale to solve for this compute inflection point. We knew, based on a lot of the research and the conversations that we've had, that those axes of complexity and performance and scale is exactly where Ray kind of fits in and brings a solution and a holistic framework to solve those problems. So let's talk a little bit about that journey of how we eventually adopted Ray, and specifically how we did this with a very high amount of velocity and urgency with our partnership with Anyscale. First and foremost, we defined what we called our AI compute engine blueprint. This is a fairly standard architecture that a lot of folks in this room are probably familiar with. We have our cloud infrastructure at the bottom. We have our data, where we're sourcing a lot of our features from, a zone to run workloads and compute, and our platform entry points, which really defines our developer experience for our machine learning engineers and our data scientists. For us as a team, this supports feature engineering, training, and online and batch inference, and then eventually plugs into our different Attentive AI products. So once we kind of had our blueprint defined and our strategy defined for what we wanted to go after, we then actually really attacked the problem, and we attacked it very quickly. In our first week, we built the core. So we worked with the folks at Anyscale to deploy Ray on our AWS compute infrastructure to get access to CPU and GPU compute at scale, a lot of T4s and L4s very specifically. We plugged directly into our data lakehouse, which we run Iceberg on S3. And then with the folks at Anyscale, we set up a proof of concept 2-tower model on Ray data and Ray train in less than a week. I'll repeat that last part. In less than a week, we went from zero, not having any platform for our AI compute engine, to proof of concept model on GPUs. So once we built that conviction, we knew that we were placing our investment in the right place, and so we moved to integrating the broader ecosystem of our machine learning platform, bringing in tools like Datadog for observability and better log tracing for our machine learning engineers and for us as an infrastructure team, integrating with open source tools like MLflow for experiment tracking, registering models, versioning those models, just kind of moving things between the different life cycles from staging to production and bringing a little bit of structure there. And really what I want to highlight here is that we did this in less than a month after that initial proof of concept. We basically kind of built on top of that building block of the core and then brought that into kind of a holistic platform solution. And on top of that, it really showed us the value of the plug-and-play nature of Ray. It was so easy for us as an infrastructure team to integrate these different tools that we as a team already supported in our clusters or in our ecosystem, and then immediately craft a platform around that. From there, from month 2+, we really focused on expanding and optimizing. We had a production-grade 2-tower model that was now serving batch inference for a lot of our customers. And so as a machine learning platform and infrastructure team, we could really double down our investment and really look at the tooling and enablement to make this more self-service. So we started getting into things like building out SDKs and abstractions for our platform interfaces to abstract away a lot of the challenges with things like PyArrow, a lot of the Ray classes, to make it easier for our machine learning engineers to templatize and patternize a lot of the things that they were trying to do and help them to move a lot faster. On top of that, we started getting into more of the online and real-time serving side of things with Ray Serve, and continuing to invest and double down into Ray as our single focal point and framework for the future. We started getting into different features like automated retraining as well. Now that we could do things a lot faster, a lot more streamlined, we can kind of unlock the next stage for us as a platform team, and ultimately plug those into our different Attentive AI products, kind of the reason that we are doing all of this. With that, I'll hand it over to Eric to talk a little bit about the machine learning efforts as we were going through this modernization from a platform side.
Yeah, so I mean, Christian's team did all the hard work. I mean, we were just moving around some code. I'd like to walk through the journey of migrating our 2-tower model, going from a single node all the way through hyperparameter tuning and all the other things that we did to make it better. I've got some code. I have no idea how legible this is, but I've highlighted the things that are interesting here. So standard code, if you've ever created a little 2-tower model, PyTorch, dataset, data loader, nothing too crazy here. What we did on the very first step is we wanted to migrate to a Ray cluster that allowed us to use heterogeneous compute. You've heard that said a lot today. That's basically having small little CPU nodes, reading in all of the data, doing some of the pre-processing, and then saturating a node that's doing the training for a two-tower model. This is incredible, and it's one of the things that really slowed us down, is that we had this inefficient use of our GPU. And migrating this was relatively simple. Highlighting kind of the relevant components here, we just replaced the dataset and data loader with Ray data, and we used its sharding and its iterative batches to then feed data in. It took a week or two to get through this, somewhere in that neighborhood. We were kind of off to the races the second we had that. So we were working in lockstep with our ML platform team. So the second step here is we started to think through how we could scale this model to be larger and use more data, was we migrated to using distributed data parallel. This is where we replicate the model across multiple GPUs, but it's still the same model. And so now you're able to effectively use multiple GPUs and train on the different batches at the exact same time. Ray actually handles the GPU gradient syncing at the end of each epoch. This further reduces the training time for each of our models. The setup of it's a little bit more complicated. This took us another couple of weeks to kind of understand through Ray's documentation. But instead of having a training epoch that feeds things in, you instantiate the model inside of that. You use prepare model and tell it that you want to use DDP as your model strategy. You use Ray Train's report functionality, which effectively reports out the different losses, because now your GPUs will have different losses. And you pass into Torch Trainer, the training epoch, as well as a scaling configuration that includes multiple GPUs. Really wasn't that bad. It was great, actually. So our last step here, we went to fully sharded data parallel. So this is really cool. This is where you actually take the model, you divide it up into different shards, and you put it onto different GPUs at the same time. And this is important for us because a two-tower model has to keep the embedding tables in GPU memory. So you really want to basically make every use of GPU memory as optimal as possible. And Ray does this in a cool way with some advanced memory optimizations. The three that we used were mixed precision training, CPU memory offloading, and gradient checkpointing. And the last two are really interesting because they effectively trade off GPU memory for GPU compute. GPU compute is fast, and we can have lots of those doing fast things. GPU memory is precious. And so we were able to massively increase the size of our model by sharding it over many GPUs. And again, continuing to use heterogeneous compute so that we were feeding in data through cheap CPUs into each of those GPUs. This was really hard for us. It took 2 letters, which is kind of a half joke, simply because there's a lot of additional configurations for the memory optimizations. But just doing the sharding was 2 letters. With this code, we effectively had the model we wanted, but we needed to go and optimize it. And so that's where we used hyperparameter tuning with RayTune. RayTune's fantastic in that it allows you to incredibly efficiently, through data sampling methodologies and early stopping optimizations, efficiently search through hyperparameter spaces as well as model configurations. This was super helpful. I put the code up here for what we ended up using kind of as a toy, highlighting the section about RayTune. It took a machine learning engineer, who, by the way, was relatively junior. I think he only had a couple of years of experience. It took him about 8 weeks to get to this. And that was an incredible testament to how easy it was for us to migrate over to Ray. And so what did this net us? We ended up with about 500 million rows of different training samples. We're actually scaling it up to about 1 billion over the next month or so, with 2,000 plus features and images. Because we have all these product images that we wanted to use. That's a 500x increase in data. Pretty cool. The model size got 10x larger, and the model train now takes 5 hours instead of 45, with near 100% GPU usage across all of our GPUs. And you're probably thinking to yourself, Eric, that's great. You probably just spent a ton more money. Except that we didn't. It was actually 2/3 cheaper for us to do a training model run on Ray with this configuration, 500x the data, 10x the model size, than it was with a single node. Ray's just that efficient. That's pretty cool. So with this model, we were able to drive way better performance. We are now I think we have 4x the amount of customer revenue being generated through product recommendations than we did with that single node. We were able to scale the data, scale the number of subscribers that are getting personalized recommendations, and make them that much better. So let's bring this back. Product recommendations are one element of the personalization that we drive at Attentive. It's an investment that we're making, and it's an investment into the performance of Ray that we're making, as it's able to unlock that scale that we need to drive personalization for 500 million plus subscribers. This is just one way that we're driving personalization, and we're really excited about the future investments we're making here. I'll give it back to Christian to talk about what we've done with, what's it been, 9 months? With Ray on Anyscale.
Yes, so what's happened since then? After the undeniable impact of our product recommendations model and a lot of the things that we've done with less than 2 months of engineering time between our teams, we knew that our investment was placed in the right place. We had built that cornerstone and that focal point around Ray, drove immediate impact and results from it, and we knew as a team from a platform side and from a machine learning strategy side that Ray was the future for us. And so since then, we've been doubling down across the board on our investment into Ray and our partnership with Anyscale to drive increasing results across the entirety of our platform and our organization. Ray has really become the focal point of our AI compute engine here at Attentive. By consolidating our investment into Ray and Anyscale, we've really been able to prioritize from a platform side of things the interfaces and really specifically the lesser thought of thing, which is the enablement, to create a self-service ecosystem for our machine learning users and ultimately help them to ship models faster, ship more impactful models, and build really, really cool things on top of Ray and our ML platform. So what does that actually look like from a number side of things? We are now nearing a 100% adoption of Ray across the entire fleet of our machine learning models. By the numbers, in the last 5 months alone, we've seen a 163% increase in Ray adoption and usage within our ML platform. And on top of that, we saw this 163% increase in adoption with just 2 platform engineers supporting the entirety of this platform. So in less than 2 months, we drove immediate impact. And in less than 8 months, we have essentially adopted Ray across everything within our platform at an incredible rate and surface area. So what's really the impact? We kind of talked before that our infrastructure was limiting our personalization and our scaling efforts. So where we are today is that our infrastructure is now truly unlocking personalization. And it's not just unlocking personalization for us, but it's unlocking personalization at massive scale. So we saw a 99% cost or reduction in cost of training and serving across models, which is an absolutely massive benefit for us as a platform team because that frees up investment for other parts of us as an infrastructure organization. On top of that, we saw a cost reduction with a 12x increase in the amount of training data that we're using per run. Usually you see those 2 axes conflicting with each other, but in this case they were going in the same direction for us. And on top of that, from an actual scale perspective, we're now processing almost 2 trillion data points for inference every single day across all of those 500 million subscribers that we're talking about earlier. So let's bring this all back and kind of why I asked everyone to raise their hand when everyone's probably thinking about lunch. And it's just to showcase that this is a challenge with absolutely massive scale. And I think it's something that we'd all like to see as consumers. We'd all like to see a better digital shopping experience. We'd all like to have more relevant and personalized messaging for us from brands. And at Attentive, and with a lot of these personalization efforts that we're now scaling across all of our products, we want to move from the current state where consumers are feeling overwhelmed, they're feeling irrelevant, to building the future that is about delivering tailored and meaningful experiences that feel natural, they feel impactful, and they build lasting connections between consumers with the brands that they love that ultimately drive purchases for the brands that we support and loyalty for you as consumers with a better experience. With Ray and with Anyscale, we're now doing this across all of our products with impactful, massive scale models. So the next time that you get a message from us, keep an eye out because you might notice something different about it. With that, thank you all, and thanks so much for the Anyscale folks.